G'day Year 7s. Today we are looking at what's called the third index law. Now we've done the first and the second index laws. The third is the strangest. It's probably in a strange way it's the easiest, but in another way it's the most confusing. It's a strange one, but once you get the hang of it, you'll soon see that it's easy to work with. Okay, so what is the law? Well, a to the power of 0 equals 1. But a can, of course, represent anything. X to the power of 0 would equal 1. Anything in brackets, a, b, c squared in brackets. Those brackets make that a, b, c squared one entire thing on its own. Put brackets around it and a 0 on the outside. That equals 1. Absolutely anything. 1 plus... donkey, not that makes any sense, to the power of 0 would equal 1. So literally anything to the power of 0 equals 1. Now, why might that be the case? Well, let me try and explain. Let's just say you have something like, I don't know, 2 divided by 2. Well, you would say, how many 2's go into 2? Well, 1. So you've always known that that equals 1. But let's calculate it using something we learnt recently. 2 over 2 is the same as 2 to the power of 1 over 2 to the power of 1, isn't it? And using our second index law, we can write that as a single 2 with this power minus this power. 1 minus 1. 2 to the power of 1 minus 1 equals 2 to the 0. So look what we've just shown here. We've shown that 2 divided by 2 equals 1. We've also shown that 2 divided by 2 equals 2 to the 0, which means 2 to the 0 equals 1. And actually means anything to the 0 equals 1, because I didn't have to choose 2. I could have chosen anything I wanted. So the rule works, okay? So now I'm just going to chuck it into a bunch of confusing questions, all the sorts of typical questions that trip kids up, and we'll see how we go. Start with the simplest. X to the power of 0 is exactly the same as the rule. That is the rule. That equals 1. Done. Oh, I've already written the answers on every second one. Okay. 2c to the power of 0. Okay, everyone gets this wrong. People remember anything to the power of 0 equals 1, but this is 2 times something to the power of 0. So this is 2 times 1, which equals 2, because the 2 isn't in brackets with the 0 applying to that 2. That's 2 times something to the power of 0. The something to the power of 0 part equals 1. 2 times 1 is 2. So you see how I'm trying to confuse you? Making just really, really subtle changes. Now we have a 2 and a variable, but they're both inside some brackets. And the power of 0 is outside the brackets. These brackets make the thing that they contain a single item. And that single item is raised to this power of 0. So this equals 1. Okay, what about this? Well, anything in brackets to the power of 0 equals 1. So it wouldn't matter how long that was. It could be 2s squared plus 16w plus whatever. So long as that whole thing was in brackets and there was a 0 next to it, that bracketed part would equal 1. Okay? So this part equals 1. And this means 2 times this part. So 2 times 1, which equals 2. Okay, well here we have some brackets, but used in a slightly different way. These brackets are actually unnecessary. I just put them in there to confuse you. The thing that is raised to the power of 0 is the x on its own. So x to the power of 0 equals 1. 2 out the front means 2 multiplied by that thing. So this equals 2 times 1, which equals 2. What about something strange like this? We've got an x plus 1 inside of some brackets raised to the power of 0. Well, don't even think twice about it. If there's a bracket on the left and a bracket on the right, it equals 1. Now, if there was something like a 2 out the front there, then it would be 2 times 1, which would be 2. But not for this one. There's a mistake. I have to go back into my notes and change that. Mr. Broadby making a mistake. Who would have thought? What's going on here? No variables. Well, it doesn't matter. All the index laws that work with variables also work with numbers. Okay? That's because variables represent numbers. Okay, 5 to the power of 0, anything to the power of 0 equals 1. Easy. Okay, 5 lots of 4 to the power of 0. Well, if it said 54 to the power of 0 like that, that would be the whole number 54 raised to the power of 0, which would equal 1. That's not what we have though. We have 5 times something that is equal to 1, which equals 5. So hopefully we're getting the hang of things. All right, getting a little bit weird now. Well, this whole part here is raised to the power of 0. So we're going to have 5 lots of 1. Okay, so 5 times 1. And then this plus 7 just comes down for the moment, plus 7. Now it's a regular BIDMAS problem. What's 5 times 1 plus 7? 12. So we were actually able to come up with a numerical answer for that one. Okay, what's going on here? It doesn't look like there's anything raised to a power of 0, but this is when you start using your index laws in combination. So this is a second index law problem initially. Let's deal with the number part first. 6 over 4. The highest common factor of 6 and 4 is 2. So 6 divided by 2 is 3. 4 divided by 2 is 2. And we put down 1q just on the top with this power minus this power. That's the second index rule. 2 minus 2 is 0. So there we go. Which equals 3 lots of something which is 1. So 3 lots of 1, in other words, just 3. And the 2 on the bottom. Okay, a particularly odd one here. Don't be confused, just follow your rules. Okay, let's do anything we can't do, we just rewrite. But anything we can simplify, we simplify. And for a couple of these slides I've noticed I've forgotten to write the word simplify. Simplify. That's always the instruction. Okay, can't simplify 1 minus x squared. Okay, we've got an m0 in the next term. So 3 times m to the 0 means 3 times 1, which just means 3. So plus 3. This becomes a 1. So 3 times 1 times n. And then the minus 3. Now we can collect like terms. Let's not forget what that means. So the terms are the chunks. And this one just so happens to be one that I can simplify a bit further by collecting like terms. Now, what are the like terms? This has an x squared and this has an n. They've got nothing to do with each other. But these two are just constant terms, just numbers on their own. so they can be combined together. They're considered a like term. So positive 1 minus 3. 1 minus 3 minus 2. And then the minus x squared comes down, and the plus 3n come down. And they stay as they are because they can't be simplified any further, okay? And you wouldn't get it wrong if you didn't do this next step, but it's normal to put the highest, the term that contains the highest power on a variable at the front. So it's more normal to write it like that, but that doesn't really matter. I think this is our last one. All right, so we're going to use all 3 index laws for this. Now, when we have simplifying that needs to happen in the numerator and the denominator before we can use the second index law, so we do so. So we simplify from left to right, both on the top and the bottom, and then write our new line there. And then for our second equal sign, we simplify from top to bottom. Okay? All right. So here we go. So we're just dealing with this at the moment. 6 times 4 is 24. And I can see m's and n's in both of those parts of the expression. So I'm going to set up an m and an n on the top. This is n to the power of 1. This is m to the power of 1. And now I add my powers, the first index law. M squared times m to the 1 is m to the 2 plus 1, so m cubed. And here I have n to the 1 and then n to the 4. So 1 plus 4 is 5. And this is over minus 12. No simplifying to be done on the bottom at this stage. Minus 12m cubed just stays the same. Okay. Now we can simplify downwards using the second index law. Positive 24 divided by negative 12. Well, that's a positive divided by a negative, so it's going to be a negative. Now, what's the highest common factor of 24 and 12? That would be 12 itself. So 24 divided by 12 is 2. 12 divided by 12 is 1. Now, m cubed on the top and m cubed on the bottom. So when the base appears on the top and the bottom, you write it once on the top, and the power is this minus this. 3 minus 3, there we go, 0. And the n5, there are no other n's anywhere, so that just stays put. All right, I'm running out of room, so I'll do my equal sign over here. Tidy things up a little bit. If we just have a 1 on the bottom of a fraction, that's not doing anything particularly useful, so we can get rid of that. This is 1 because it's m to the power of 0. So that's just minus 2 times 1 times n to the 5. So we can get rid of that, and the answer is minus 2n to the 5. Okay. There we go. So when you watch these videos, guys, you always have the option to go back into, for this topic, it would be the algebra folder, and find this PowerPoint. And sometimes it'll be a slightly different version, easier for you to read. And you can look slowly through all the setting out and stuff, or rewatch the video. But these are always available on Classroom, okay? All right, guys, that was the third index law, things raised to the power of 0. Thank you for listening. I'll see you next time.